This is a recording of a slightly longer version of the talk I gave at the Small Bodies Assessment Group in January 2024. So just by way of context, I work at Caltech IPAC. Caltech is, of course, the California Institute of Technology. IPAC used to be an acronym, and it used to resolve to the Infrared Processing and Analysis Center. As per our management, it is no longer an acronym, it is just IPAC in all caps. It is physically at Caltech, but it's unaffiliated with the astronomy department. We're a totally separate entity. We have 35 years of experience with archives and science operations, and it turns out we also hire a lot of astronomers and programmers. We've got several jobs open now, and we have a visiting grad student 6-month fellowship, which you should watch for if that is of interest to you. We have several different archives at IPAC, but in the context of this group, IRSA is the most relevant. IRSA, which is where I work, is NASA's Infrared Science Archive. Our charter is to provide an interface to all of NASA's infrared and submillimeter data sets. So we're talking like a micron to a centimeter. It was founded in 1993, and it was the original home for IRSA data, which were obtained in 1983. About 15% of all astronomy referee journal articles published worldwide use data that ultimately came from IRSA. So we have a lot of data at IRSA. We have just a ridiculous amount of images and rows of catalogs in databases. We have all-sky coverage in 24 bands. So in the context of what y'all are interested in, there are basically 3 kinds of solar system object SSO searches that you can do at IRSA. We have observations that were conducted of known objects for which there was a deliberate pointing at an object and tracking on the object. So that's only relevant for observatories that deliberately point. So like they had a TAC and a review process, and the telescope deliberately pointed at and tracked on a known object. So that's like Spitzer, Herschel, Sophia, IRTF. All those data live with us, and those telescopes deliberately pointed at and tracked on known objects. There are also things that we've called pre-covery searches. That is, given the orbital elements, you can get a predicted location as a function of time, and then you can look through the existing observations that are obtained, of course, with times and positions attached, and then you can look for serendipitous observations of your object. Now, there's no guarantee that the object was detected or noticed in those frames, but given the orbital elements and the times and locations of the observations, the computer will serve up to you the frames that it thinks are relevant to that object. So for observations from survey telescopes like WISE or ZTF or Planck or 2MASS, it will serve up to you the frames that happen to be of that section of sky at the relevant time. But it turns out that Spitzer and Sophia both do large patches of sky that are relevant to solar system object searches. So you can also do those pre-covery searches looking for serendipitous observations out of the Spitzer and Sophia archives as well. Now, the third kind is pipeline detections. In other words, when the WISE pipeline was run, if the object was known about and detected by the pipeline, there is a part of the pipeline that is smart enough to say, aha, this is a known solar system object. I'm going to tie all of these apparitions together and identify them as being the same object associated with this name. So there's 3 different kinds then of these searches. So let me show you examples of each of these. This is a Spitzer pointed observation of Apophis that I showed in the talk to the SBAG. Let me show you how I got here. So from the IRSA homepage, if you go to Spitzer and then the Spitzer Heritage Archive, by default it drops you into a position search, but for what you want a moving object search. Note that you can also do recovery, but for this example I'm going to do a moving object search. I can put in the name of the object. Now, everything is tied in all of these searches to NAIF ID. So if you just put in the name, that's not enough. You have to give it a second to go look up the NAIF ID and then pick that. And then it fills out the NAIF ID. Now, you need to ask it for what kind of search results you want. Now, for that, you need to know a little bit about, because this is an archive custom to Spitzer, you need to know a little bit about Spitzer observations. An AOR is the fundamental unit of Spitzer observing. The post-BCDs are high-level products, level 2 products from the pipeline, so like mosaics, which means that it might remove moving objects. And level 1 is the individual frames. So search. It found an observation, a pointed, targeted observation of Apophis. That means pointed at and tracked on Apophis. This is the details of the proposal that went with that. This is an indication of the data coverage. So each one of those polygons is an individual frame overlaid on what happens to be a 2-mass image in the background. This is the screenshot that I used in the talk. But if you want to see the actual data frames, here is the mosaic. The object is probably not there in the summed up mosaic. You probably need to go to the individual frames. Now the target, which you may or may not be able to see, let's change that overlay so that you can maybe see it a little better. There it is. So that's where Apophis is in that frame. If we go to another frame, it's going to be in a different location. There it is. So now you've got the individual pointed observations, and then you can download them, clicking to download all of them, and then prepare download. So that's a pointed observation done with Spitzer of Apophis. Now let's do a pre-covery search. Let's look in WISE to find which images caught Apophis. Let's go back to the IRSA homepage. This time let's go to WISE, and then the WISE image service. Now WISE, remember, is a survey. So for this, instead of searching by position, we're going to search by solar system object. We're going to put in Apophis again. Again, we have to wait for it to resolve it to the NAIF ID and then pick it. Now, you can constrain it by date, because of course, the longer the time range over which you look, the less accurate the elements get. I'm just going to tell it to go ahead and look over the whole archive. I'm going to tell it to look over all sky and NeoWise reactivation. There's lots of things that I could say about which image set you want. There's actually another movie that goes through in more detail about what all this means, but I'm not going to go through that now. But we're going to look at the NeoWise reactivation data search. Okay, it took a little while, but it did come back. This is the orbital path that it calculated. And if you want to see exactly where it calculated, that's the orbital path that it calculated drawn on the sky. So that is one of the screenshots that I had in the talk. So over here, these are the individual frames that it found. If you go to the data tab, again, let's change that overlay so that you can maybe see it a little bit better on the screen. All those little red reticles are the locations, the apparitions of Apophis in those individual frames. So you can see that it started finding frames for it at 59,201. Now there's no guarantee that it is actually detected in those frames, but those are the frames that it calculated where Apophis should be. So that's one of the other screenshots that I put in the talk. All right, so now the last kind of search is, I'll do another WISE search. So this time we're going to go to catalogs and we're going to go to WISE, NeoWise. So you can see in here, there's many different WISE deliveries. What you want to look for this kind of a search is the known solar system object possible association list. Here's where it gets a little bit tricky. The orbital elements, the object needs to be known, and the orbital elements need to be known well enough at the time the pipeline was run in order for this kind of search to work for your object. There are so many more objects known now of the time of the NeoWise pipeline being run. You go back, the last time that the 2-mass pipeline was run, there was many fewer sources known. So trying to do this kind of a search with the 2-mass pipeline is going to be significantly harder because there was so many fewer objects known. And you can even see the evolution of this with time within the NeoWise deliveries. Because, for example, the all-sky known solar system object possible association list has fewer objects in it than the NeoWise known solar system object possible association list. So we're going to pick the NeoWise R known solar system object list. Now, we don't want to do a single object search. We want to do an all-sky search because we want to find all of the apparitions of Apophis. Now we're going to go down to the bottom, and there's a handy example. Object ID like Themis. We don't want Themis. We want Apophis. Okay. Run query. Okay, it's come back. It found 31 observations. And the first apparition that it actually found, the first detection, about MJD 59,304, which I believe is late 2020. So that was the first time that Apophis was bright enough and the orbital elements were known well enough that the pipeline was able to identify it securely and tie it together with other apparitions. So that's what I was working through here. Turns out there is another way to do a catalog search. If you go back to the catalogs button and WISE, NEO-WISE, and then instead of the known solar system object possible association list, go to the single exposure source table. Now, instead of a single object search or a multi-object search or an all-sky search, this time you want to do a moving object search. And now you can see the search changes. You can pick asteroid or comet, but just like before, you want to put in the name of your target. Now, unlike the other tool where you have to pick the NAIF ID right away, this time the NAIF ID is going to be resolved under the hood. But now it's going to go resolve that, calculate the orbit, and get the relevant exposures. So it's come back a little bit different interface than before, but that's the calculated orbit. And if you scroll down, these are all the photometry that it found in the single exposure source table. So there's tons more videos. If you found this video, you're in the right place to find all of the other videos. There is a playlist specifically for solar system astronomers. I made a short link for it there. That's IRSA_SSO vids. There you can also use the QR code there. We do have a newsletter, electronic email newsletter that's sent about monthly. We advertise new data releases and tools like Jupyter Notebooks, things like that, partner events like conferences or proposal deadlines. We also advertise this on social media, Facebook or Blue Sky if you're on there. You can also access the archives of the newsletter on our website. If you're not already subscribed, please do sign up. And I also, if you want, I can do a longer version of this kind of a demo. I've been doing lunch talk level IRSA demos online over Zoom. So if you'd like me to do one for your class or your department or your group, just let me know through the help desk. And I'll just leave this up at the end so that you can copy it.